Let's talk about note card 15, horizontal stretch or shrink. And this is going to change a little bit. The prior note cards 12, 13, and 14, the vertical shrink, stretch, the vertical shift, the horizontal shift. Before you can do any of those, you have to graph the parent function sine x or cosine x. And for those of you that have been doing your practice work, you're getting pretty good at that, and you're finding that it's not too difficult. Today, we're going to talk about horizontal shrink and stretch, and things change up a little bit. Because first you have to find the period. Now, with the other transformations from note cards 12, 13, and 14, we sketch the parent function over the period 0 to 2 pi. But if it's a horizontal shrink or stretch, then that can change. Okay, so if I have, and this is just kind of explaining a little bit, I'm not going to go into detail right here, I'm just kind of tell you what's going to happen. Our normal curve, if it was like this, if there was a shrink, then it would be a lot, it would oscillate a lot more, okay? If it was a stretch, then it would oscillate less, okay? And so those are the things we're going to be talking about. That's what's going to be happening to our curves, and we have to know how to graph those by hand. And so this note card tells us how. It says the first thing we have to do is find the period. And the way we find the new period is the period is equal to 2 pi divided by b. Okay? And b is going to be the number that's in front of x. Okay? So then we break that length or that period into 4 parts, and the way we do that is we multiply the period by 1/4 to get the first x value, and then we multiply it by 1/2 to get the second, multiply it by 3/4 to get the third, and the fourth is the actual period itself. Then we want to graph the basic sine or cosine curve, and then we want to do our transformations as we've been doing those. Let's look at an example. Y is equal to sine times 4x. Well, this is a little bit different than what you've been seeing on trig graphing 2 and 3. On trig graphing 2 and 3, there wasn't a number in front of the x, it was just 1. Or I say there's not a number other than 1 in front of the x. So we have this number in front of x that's not 1, and so we have to find the new period, because if there's a number in front of x that's not 1, that tells us there's a shrink or a horizontal shrink or stretch. And so we find our new period, and b is 4. So that's how I've got, remember up above on the note card it said the period is equal to 2 pi divided by b. And since b is 4, it's 2 pi over 4, which reduces to pi halves. So the period is pi halves. Okay? The entire sine function is going to be from whatever the beginning part is, and it's going to end at pi halves. It's going to repeat every pi halves units. So we can find the first value on the period by multiplying our period by 1/4, and 1/4 times pi halves is pi 8. So the first increment is going to be pi over 8, and then we go through everything, and so we get the entire period looks like this. Now I want to make my own graph here. Remember the way we've been doing this, when we would graph our sine or cosine function first, the first thing we would do is we'd have to set up our graph. And we would have, let me change my color. In the past, or with trig graphing 2 or 3, when there's no horizontal shrink or stretch, we would start this with pi halves, and then we would do pi, then we would have 3 pi halves, and then 2 pi. And we would graph our sine or cosine curve, knowing that the minimum value is going to be 1, the maximum value is going to be 2. And if I was graphing sine, I would start at the origin, and I would come up to here, and then go down through pi, and then down to this point, 3 pi halves, comma -1, and then back up to here, and then that would be my parent sine function. If I were doing cosine, I would start up here at 0, 1, go down through here, have the minimum at pi, comma -1, and then back up through here as an x-intercept, and then up to here, and then even though that's not a very pretty looking cosine curve, that's basically what we would do to start. Well, now since our period changes, we can't do that. We have to find our new period. Before, our period was 2 pi, but our period is not 2 pi anymore. But I still want to kind of approach it in the same manner as far as splitting up this xy plane here into 4 parts. But instead of doing pi halves, pi, 3 pi halves, and 2 pi, I have to find my new period. My new period I found to be pi halves. That means all the way over here at the end, this is pi halves. Okay? So the first x value, or this first increment here, the way I find that is I multiply the period pi halves times a fourth, because this value is 1/4 of pi halves. And so I get that to be pi over 8. And then the middle part, I multiply it by half, and I get that to be pi over 4. And then the third value, I get that by multiplying the period by 3/4, which is 3 pi over 8. Now I have my graph set up, and since I have sine x, I would do sine this way. Negative 1 and 1, the lowest and highest values. And if you remember that sine starts at the origin, it comes up to the first value here, then it's going to go back through the x-axis at the middle value, and then at the third value it's going to reach its minimum, then it's going to come back up through, and that's how you would start this problem. Now that is the answer to this problem, because the only thing that's happening here is a horizontal shrink. Okay? Since we have this horizontal shrink going on, this is the only thing we had, and so this is my answer, and it looks like the same sine function that we've been drawing, but it's much shorter, because normally when we would do the sine function, this first piece would go, it would go up to here, and it would start going back down at this point, so it's shortened up, it's shrunk horizontally. But that's how you do it. You have to find your new period. Let's go on to the next example. And so here we have y equals cosine 1/3 x, so b is 1/3. So I find my period. Remember the period, the new period is found. It's equal to 2 pi over b, or in other words, 2 pi divided by b. And so that's what we have here. 2 pi divided by b, which is 1/3. And we get 6 pi because, remember, the way you do this is you have 2 pi divided by 1/3, which is 2 pi times 3 over 1, or just 3, which gives us 6 pi. So my new period is 6 pi. And so I'm going to make my xy plane here. And I'm going to split it up into 4 parts, 1, 2, 3, 4. But I have to know what are the first, second, and third values. Well, if my period is 6 pi, that tells me that this value over here is 6 pi. So I find the first value by multiplying 6 pi by 1/4, and I get 3 pi halves. So this value is 3 pi halves. I get the middle value by multiplying the period 6 pi by 1/2, and I get 3 pi. And I get the third value by multiplying the period by 3/4, and I get 9 pi over 2. Now, it's very important that we get these values because remember, we're not just going to be dealing with problems that just have a horizontal shrink or stretch. We're going to be dealing with some sine and cosine curves that have a horizontal shrink and stretch. They might be reflected in the x-axis. They might also have a vertical shrink or stretch. They might also have a horizontal or a vertical shift left, right, up, or down. Okay? And so you still want to do these in the order of operations from the parentheses, then you do your multiplication, and you're adding and subtracting first. But if you have a horizontal shrink or stretch, remember this is the first thing you have to do. Find your new period and sketch your new parent curve, and then start from there and go from there. So this is how you do this. And I will say that if you noticed on here we have a horizontal when something that you may or may not have noticed, when you have a value in front of b that's a fraction, it looks like we have a horizontal stretch here. We had a fraction in front of x, and that stretched us out because remember, if this is 3 pi, 2 pi would have been right in here somewhere. And my basic cosine curve would have looked something like this. It would have done the whole pattern over the period from 0 to 2 pi. But because of that 1/3 value in front of x, we ended up stretching it out over the period 0 to 6 pi. So there's only one thing different here. If you have something in front of the x, just remember you have to find the new period and start there first. And then you can do the rest of it, which you should be getting good at by now, if you haven't done.